On Earth, when we think of ice, we almost always mean frozen water, solid H2O, glistening and familiar. But on Mars, the story of ice takes a fascinating twist. Mars is home to not just water ice, but also dry ice, which is actually frozen carbon dioxide, a substance rarely seen in solid form on Earth. Water ice on Mars is incredibly important, as it hints at the planet's potential to support life and provides a vital resource for future explorers. Dry ice, on the other hand, reveals much about Mars's thin, fragile atmosphere and the planet's extreme, relentless cold. The average temperature on Mars is a bone-chilling -80 degrees Fahrenheit, far colder than most places on Earth. While water ice can exist at these low temperatures, carbon dioxide only freezes when it gets even colder, forming dry ice in the most frigid regions. During the harsh Martian winters, the atmosphere itself can freeze, causing carbon dioxide snow to fall gently onto the surface, a phenomenon unique to Mars. The result is a landscape where familiar water ice and exotic dry ice often exist side by side, creating a truly alien environment. Studying these different types of ice is essential for scientists, as it helps unlock the secrets of Mars's past climate and its potential for future habitability. Water ice and dry ice behave in unique ways, are found in different locations, and each tells a distinct story about the red planet's history. Water ice suggests hope for life and exploration, while dry ice highlights the planet's harsh, unyielding climate. Together, these two types of ice are crucial pieces of the Martian puzzle, helping us understand this mysterious world. Mars's dual ice nature makes it a truly fascinating and complex world, inviting us to keep exploring its frozen secrets. When searching for ice on Mars, the North and South Poles are the most obvious and dramatic places to start. These regions are easily recognizable from orbit, with their bright, reflective surfaces standing out against the planet's rusty red terrain. The polar ice caps are made up of a fascinating mix of water ice and dry ice, which is frozen carbon dioxide. These layers build up over thousands of years, creating a record of Mars's climate history. The North Pole features a massive permanent water ice cap that remains year-round, while the South Pole is covered by a thicker layer of dry ice, especially during the Martian winter. But ice isn't just limited to the poles. Across many regions of Mars, water ice is hidden beneath the surface, sometimes protected by just a thin layer of soil or dust. Both rovers and orbiters have detected this subsurface ice, sometimes finding it just inches below the ground, making it surprisingly accessible in certain locations. For future astronauts, this buried ice could be a game changer, providing a vital local water source for drinking, growing food, and even making rocket fuel for the journey home. Dry ice, on the other hand, mostly forms at the poles, or appears as a temporary frost in especially cold regions, vanishing as temperatures rise. The shifting patterns of ice and frost reveal just how dynamic and active Mars's climate can be, with seasonal changes that reshape the landscape. Mars's icy landscapes are full of surprises and potential, offering clues to the planet's past and hope for future exploration. Martian ice holds clues to Mars's climate history and potential for life. The layers in the polar ice caps are like a timeline of Mars's past. Studying these layers helps scientists understand how Mars's climate has changed. Water ice is a prime target for astrobiologists searching for life. Conditions below the surface might be more hospitable for ancient microbes. Martian ice is also a critical resource for future human exploration. Using local ice for water and fuel could revolutionize space travel. Martian ice isn't just a curiosity, it's a key to the future of space exploration. The future of Martian ice exploration is about getting a closer look at the mysterious and captivating ice formations that dot the planet's surface. Scientists are eager to drill into the ice and analyze it directly, hoping to uncover clues about Mars's climate history and potential for supporting life. Future missions will search for biosignatures and signs of past life, aiming to answer the age-old question of whether life ever existed on the red planet. The potential reward of finding life is enormous, offering insights that could redefine our understanding of life in the universe. Martian ice is central to the dream of building a human settlement, providing essential resources like water for drinking, agriculture, and even fuel production. The first explorers will rely on local resources for survival, making the presence of accessible ice a critical factor in mission planning. Accessible water ice will determine where the first Martian base is built, guiding the selection of strategic locations for long-term habitation. The story of ice on Mars is one of potential and discovery, a narrative that continues to evolve with each new mission and technological advancement. As technology improves, we'll unveil the secrets hidden within Mars's ice, revealing the planet's past and its potential to support future human life.